Okay. So, in this session, mm, in this session, we have to discuss the Einstein relation. Okay. So, first of all, see the recap of all the things. Actually, before studying the laser in semiconductor, we have to examine the simple two-level atomic system where the atom can stay. So, actually, there is two atomic system level where atoms can live is E1 and E2. Okay. So E1 and E1 defined as a lower state and E2 defined as a higher state. So atom can move between the E1 and E2s. So in 1917, in 1917, Einstein, in 1917, Einstein. So Einstein, so the atom can interact with light in a three process. So at Einstein explained, Einstein explained, the atom can interact with a light in three way. First one is absorption. Okay. Second is spontaneous, and third one is stimulated. Okay, stimulated. So absorption mean atom absorb the photon and jump from E1 to E2. Okay, and spontaneous in which spontaneous atom in E2 fall to E1 on its own and releasing the photon randomly. Okay, stimulated emission mean photon of frequency f triggered and excited the atom to emit the another identical photon. Okay, this is a key mechanism needed for the all the laser action is coherent in same direction and same phase. Okay, after that we have to understand what is thermal thermal equilibrium. Okay, thermal equilibrium and the Boltzmann uh, Boltzmann Boltzmann population. So at thermal equilibrium, the population of energy follows the Boltzmann statistic in which N2 by okay N2 by N1. Okay, N2 by N1 is equal to G of something. So in which simply we see the N2F relationship. In N2 by N1 is equal to G by something. All these things. So okay, this is a Boltzmann relation N1 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 this one G1. Okay, and this is equal to exponential part of minus hf by kt. Okay, so whenever I explain we can write this one. So in this equation, what it at thermal equilibrium the population energy level follow the Boltzmann statistic. Okay, so n1 and n2 denote the number of atom in the lower n1 and lower and the higher. Okay, lower and higher, and G1 and G2. G1 G2 explain the degeneracy or number of sublevels. Okay, and HF you already know HF is equal to simply E2 by E2 minus E1. Okay, so we simply know this one, and okay, so N1 represent the number of atoms and this one. Okay, so this means that at a normal temperature more atoms stay in a normal temperature. It explained that the at normal temperature, at low temperature, yeah, normal temperature, normal temperature and normal temperature more atoms atoms stay at okay in the lower level. Okay, lower level uh, because the relation of E minus something, because the relation between E minus hf by kt is very small. Okay, so thus n2 is far less than n1. Okay, so after that we have to understand what is transition transition rates. Okay, in which Transition rate is the atom jump from the one state to another state, that is mean transition rate. So R12 is equal to transition rate is equal to, this one is known as the transition rate. Okay, and the formula for this is equal to n1 rho f or b1 by b2. So the spontaneous emission, the spontaneous absorption rate, this one is absorption rate. Okay, when we discuss about the spontaneous emission rate, for that we have to write r spontaneous. Okay, in this we simply write n2. Okay, number of atom in higher level, or a to 1. Okay, for stimulated we write simply uh, n2 row of f, like b2 to 1 by something. So this one is for the absorption rate, this one is stimulation rate, and this is spontaneous rate. Okay, the total downward transition is equal to, total downward transition is equal to, so total downward transition is equal to this one. So whenever total downward transition मतलब 2 to 1, so it look like n2 by n1 and n2, or a2 by this one. Okay, for the n2 row of this one, b2 by b1. Okay, so simply this one is for the total the 2 1 is equal to, the total absorption rate is simply we can say at the stimulated plus spontaneous. Okay, and for the system thermal equilibrium condition, for the thermal equilibrium condition, it term as the n1 row of b1 b12. Okay, and for this is equal to n2 row of b21. Okay, all this one. So whenever we have to find the row f, so through this equation we can find this one. Okay, the final equation for this one is equal to rho f. So this one is the Einstein constant, Einstein relationship. So Einstein relationship between, what is the relationship between b1, this one, and b21? So we simply write as b12 is equal to g2 by g1 and b212. Okay, all these things after relationship between all these things. So the final equation. So anyway, so thermal equilibrium, at equilibrium we simply said rate of this one is equal to rate of this one. Okay, the upward transition is equal to the downward transition. So setting up the two rate equal to given equation. So b, in which this one b1 b2, this is absorption coefficient. Okay, absorption coefficient and stimulated coefficient, and the spontaneous, and a2 is equal to a21 is equal to spontaneous emission coefficient, all this term known as. Okay, so spontaneous emission relationship, spontaneous relationship is equal to this one. Okay, in which we can write a2 by a a21 by b21 simply as a 8 pi h f cube by c3. Okay, we simply write like this one. Okay, okay, based on this question is framed. So the spontaneous, so in this case we see that the spontaneous rate, so we can see the spontaneous rate and stimulated rate emission rate is equal divided by the spontaneous emission rate. We simply write this one. Okay, so b21 rho f divided by a2, simply with this one. Okay, so we can write as 1 of e the power h by kt minus 1. Okay, we can write this one. Okay, this one is clear. Based on some question, given. Okay, based on question is given like calculate this one. Okay, based on question, calculate the ratio of stimulated. So when we have to calculate, okay, so we have to everything is running well. Okay, okay. So in this way, the ratio of stimulated emission rate to the spontaneous emission rate of incandescent lamp. Okay. So in this case, our temperature is given. Okay, and the wavelength is given. So we know the formula of the stimulated by the spontaneous. What is the formula? Is simply like E exponential of we simply write the formula mm, HF. Then what is HF by KT? HF by KT minus 1. HF by KT minus 1. So E is given. Okay, H formula is given. Planck constant something. Frequency, how we get the frequency? So wavelength is given. So through wavelength, we simply F is equal to C lambda. So which we can find the frequency. So we put the value of frequency here and simply and KT, the Boltzmann constant is simply given as 1.38 into temperature is given this one and minus 1. So all these are the exponential part and simply minus 1. So this one is the answer. Okay, so here the formula. So important relationship between the ratio of the ratio of stimulated rate to spontaneous emission given as follows. Okay, why laser is needed for the population inversion? So to make a laser, so why we need a laser? Because to make a laser we actually need a stimulated emission far greater than spontaneous emission, and stimulated emission is greater than the absorption. Okay, for this equation we require the number of atoms in the higher energy state greater than the n1. So this is called population inversion. But in the thermal equilibrium or Boltzmann distribution, so n1 is greater than n2. So we can never get the population in so we never get a population inversion. So in simple two level system, hence the real laser use three level of a three level or four level. Okay, and this figure shows that and this figure shows this is a figure explanation in a thermal equilibrium. So in this graph we can see that n2 for the higher level, n1 for the density of the atom in this so n1 for the higher level and lower this one. So most atom are most atom in the lower level E1. So we can see most number of the atom in the lower level and the less atom exist in the higher level. Okay, we can see. And the Boltzmann distribution of the system is a non-equilibrium distribution. So for the non-equilibrium, so population inversion, in which we uh, simply said that external pumping rise many atom to the E1. So using the external pumping, we see that the maximum number of atom exist at the higher level. Okay, and the lower level exist at lower level. Okay, so in one sentence when we have to explain what is this, Einstein showed that the absorption, spontaneous and stimulated emission are mathematical link, and at normal temperature spontaneous emission dominate. Okay, to get laser action we must create a non-thermal condition where the upper level population exceeded the lower and call a population inversion. Okay, so till we cover the population inversion things. Okay, okay.